looking at your paper, it says joining equal sets experience, and I want you to pay attention to joining equal sets because we've already talked about this action before. And I want you to reflect back a few weeks ago when we started talking about multiplying decimals and how we were joining equal sets at that time. So now what we're going to be doing is learning how this is related to fractions. So the good thing, boys and girls, is we do not need to learn a new action because we already know that if we're putting sets that are the same together, then we're joining them together, and a faster way to join things together would be multiplying. But now what we need to concentrate on is when that's not a whole number with a decimal. Instead, if it's a fraction, what are we going to do to find the answer? So join with me in reading about the Garza family. It says the Garza family was eating Chex Mix cereal for a snack. They bought four boxes of different kinds of cereal and ate 2/3 of each box. How much cereal did the Garza family eat? So I'm going to go back and I'm going to think about my question. How much cereal did the Garza family eat? And just kind of writing down in this area, I know it says fraction strips, but we're not going to do that here. We're just going to jot down some details. We want to know who's in the story and what are they doing. So we know that it's about the Garza family. And they're eating cereal. Eating cereal. Okay, so now that we know that we're talking about the Garza family and they're eating cereal, we want to go back and look and see, well, what is it that they're eating? Well, they have 4 boxes of different kinds of cereal, so I'm going to write that down. 4 boxes. And we know that they ate 2/3 of each box. 8 2/3 of each. So now that I've got that information, I'm going to use this representation, which is our picture model, to model what's happening. So I'm going to take my pencil, and I see that I have 4 boxes, so I'm going to go ahead and label this box 1, box 2, box 3, and box 4. There's my 4 boxes of cereal. And I know that they ate 2/3 of each box. So they ate 2/3 of the first box, and I know that this is 2/3 because I have 2 of the 3 pieces. I'll shade that in. I know that they ate 2/3 of the second box, so I'm going to shade that in. They ate 2/3 of the third box, so I'm shading that in. And they ate 2/3 of the fourth box. Okay, so now that I have my pictures looking like this, your picture should match mine. I see that I have 2/3, 2/3, 2/3, 2/3, and I'm actually going to label that because labeling is super important. Anytime we have a picture model that's given to us, we should be labeling, and if we are creating or drawing a picture model, we want to always label what it is that we have. So the action that we're focusing on today is joining equal sets, which is J, E, S, and really what is joining equal sets? It's repeated addition. Repeated addition. But we know that a more efficient way of adding things together would be multiplication. So I'm going to put a little multiplication sign underneath JES. And so that repeated addition equation would just simply look like 2/3 plus 2/3 plus 2/3 plus 2/3. And going back to adding numbers and adding fractions, we know that we can only add the numerator 2, 4, 6, 8. And we do not add the denominator, so there's 8/3 here. 1, 2, 3, 4, 5, 6, 7, 8. 8/3, and that will give us our answer. But unfortunately, this fraction here is an improper fraction, so we can't leave it as 8/3. We need to regroup it and think about, well, how many groups of 3 are in the number 8? And there are 2 whole groups. That would give me 6. And so the difference between 8 and 6 would be 2 left over, and 3 would make my denominator. So another name for 8/3 is 2 wholes and 2/3. And that makes sense, because if I were to go back to my model, I could quickly say, well, this piece could go here, and this piece could go there, so that would give me my 2 whole models, and then I would have my 2/3 left over. So yes, that makes sense. Let's look at our multiplication equation. Multiplying fractions is going to be way easier than adding and subtracting fractions. So what we first need to do is think about, well, if we're talking about multiplying, how many groups do we have? Well, we had 4 boxes of cereal, and we had 2/3 in each. So we're going to take our 4 groups and we're going to multiply it by 2/3. And if you remember, when we were talking about decimals and we were talking about making things more balanced, I said, hey, this whole number 4 needs to be more like a fraction. So to make it look more like a fraction without changing the value, we're going to add that fraction bar and we're going to put a number 1 underneath. And then we simply just say numerator times numerator and denominator times denominator. And that's how we're going to be solving this. So 4 times 2 will give us the numerator of 8, and 1 times 3 will give me the denominator of 3. Again, I have an improper fraction, so I can't leave it like an improper fraction. I've got to go ahead and make that change into a mixed number. So how many groups of 3 are in the number 8? There are 2, and that would give me 6, and 2 left over would give me 2/3. So when I glance back at these should match, and yes, math should make sense, because that is exactly what would happen with my picture. If I have 4 groups of 2/3, then I could again take this piece and put it here, this piece and put it here, and I have 2 wholes and 2/3. Turn over to the back, please. And on the back, we have a number line. So basically what we want to do on our number line is we want to bring over the details from the front. And so we're going to start with our 4 boxes. And we know that we ate 2/3 of each. Now, I love the number line for fractions, because if you're good at the number line, then you will be able to find your answer using the number line. You won't even have to do any multiplying or dividing. You just have to do some careful labeling. So the first thing that I want to do is I notice that I have 4 whole numbers representing the boxes, and I want to break these boxes down. So if we think about the picture on the front, our model for each box was broken down into thirds. We know that we have a denominator of 3, so that's exactly what we're going to carry over to our number line. We're going to divide each whole into 3 equal parts. So I'm going to quickly divide that into thirds, divide this into thirds, divide this into thirds, and divide this one into thirds. now that I've got my thirds divided out, I'm going to take my pencil and I'm going to do some labeling. So on the top, I'm going to write my improper equivalent. And on the bottom, I'm going to write my mixed number equivalent. And so I'm just going to start by counting. Improper is pretty easy. So I'm just going to say, well, this would be 1/3 of the number line. This would be 2/3 of the number line. 3/3 is the same as 1 whole. 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, and 12/3. And 12 divided by 3 is 4, so I know that I've done it correctly. Now I need to label the bottom, but we're going to label the bottom using our mixed number format. So again, when we start off at 0, we're just going to start off with something that's less than 1, so we have 1/3, and 2/3, and then 3/3. So those are all the same because they're all either less than 1 or exactly 1. Now we have our mixed equivalent. So now we have 1 and 1/3, 1 and 2/3. And 1 and 3/3 would be the very same as 2 wholes. Continuing on, now we have the whole number 2, and we have 1/3. We have 2 and 2/3. And 2 and 3/3 is the very same thing as 3 wholes. And then finally, we have the whole number 3 and 1/3, 3 and 2/3, and 3 and 3/3. And that's the equivalent to 4. So if I go back and I think about my story and I think about the 4 boxes, I need 2 colors to do some shading. So I'm going to alternate between my orange and my purple, and I'm going to start with the first box. The first box we ate 2/3, so I'm going to shade that in. 2/3. I had another box and I ate 2/3 of it, so I'm going to shade that in. 1/3, 2/3. I had a third box, so I'm going to go back to my orange shading and get in 2/3. So there's 1/3, 2/3, and then I'm going to end with my fourth box, and I'm going to get 1/3, 2/3. And when I have that information, I'm going to box it in with my pencil. And guess what? 8/3 is what we got on the front, and the equivalent to that is 2 and 2/3. So the number line makes sense with our picture from the front. So let's think about my thinking. What do we have going on here? Here's what I know. I know that we know the Garza family had 4 boxes of cereal or groups. They ate 2/3 of each box. The Garza family ate 4 groups of 2/3 each. And when 4 groups of 2/3 are joined, the product is 2 and 2/3. So right now, in your own words, I want you to go back and I want you to think about our representation, our picture from the front, and our number line. And I want you to think about, how are they alike? What things are you noticing that are the same? You should be able to jot down at least 2 items and be ready to share with me in class later on.